Here we go. This is lesson 4, section 5. This is about, it says parts of similar triangles, but really that's kind of ambiguous. Parts, we don't mean, when we said parts before, when we said CP, that was stuff like just the segments and the angles of a triangle. Now, this time we mean parts as things like angle bisectors, altitudes, and medians. Oh my. All right, and then there's one other triangle bisector theorem coming up. Okay, so we knew that the sides were similar and the angles were congruent, but life gets a little more interesting. All right, so here's those big three things I were just talking about. If triangles are similar, we're going to have this proportion between thing 1 and thing 2, right? Like all the fractions a over b equals f over g. Sorry, ab equals f. The ratio of ab to fg. So ab over fg equals ac over fh, etc. The ratios of the perimeters are also that same fraction, which sometimes we call the scale factor. Well, these things like altitudes and angle bisectors and medians, those lengths can also be put in that same relationship. These are pretty easy to prove because we can prove we have similar triangles in these smaller triangles each time. So it's not that hard to prove, but I don't think we're going to make you prove that. Just realize that this is kind of extending similarity to cover a few more relatives of the triangle, not just the sides. All right, so here's one example. What's the deal going on here? If these two triangles are similar, oh, it doesn't say they're similar, so are they really? KLM, is that similar to ZSY? It looks like it is because of angle. Great. So I've got great big triangles that are similar. And you know what? I'm going to write that out because I want to make sure I keep track of this in the right kind of order. And you know what? If this were a proof or this was this type of question, you have to say this. So triangle KLM, that is in fact similar to K goes with Z, L goes with S, and Y is the last one. If you really wanted to know why, I thought that I saw that there. Yep, the angles that are marked are those. Okay, so since the triangles are similar, then the altitude stemming from M should be similar to the altitude stemming from Y. Or not similar, sorry, proportional. So I should be able to put 16 over X in the same proportion as any sides that I can pair up. And there's a 15 over here in the same triangle as the X. I'll put the 15 down here. And then what does that go with? 15YS, 15YS. Okay, that goes with LM, which would be the 24. So there we go. 16 over x equals 24 over 15. This bothers me because I could reduce it, divide everything by 3. Yeah. 5. So that produces, sorry, I kind of just low on the page. 16 times 5 equals 8x. I think that means x is going to be 10. Okay, great. All right, find the value of x here. Well, again, we have two big triangles. Hopefully they're similar because if they are, look what I've got drawn here. There's a median and there's another median. So hopefully the medians will be similar. These, yes, are similar again by AA. I'm not going to bother writing that this time. I don't think it's going to be tricky to figure out. I don't know. It was kind of nice. You know what? Here it was nice to know, okay, when I needed this 15 to be similar to something, do I use the 20? Do I use the 24? I kind of like to see that there. Not a bad habit to get into. Okay, let's do this. So triangle ABC is similar to triangle. Okay, the double tick is U, B is the single tick, so the single tick is VW. Great. So yeah, because I already know it's going to be something like, I know the medians are going to compare. 13.5 over 9 equals, but then, okay, where do I put the x? Well, I put the x there, and x goes with what? Oh, I guess there's only one thing to worry about over here. It's 3. It's got to be 3. It's the only thing that's given. Is that really true? B to D, is that the same as, oh, that's really the same as V to Q, but you know what? V to Q is also 3. Because there's this midpoint here, just like this is also x. Yeah. All right, so I got 13.5 over 9 equals x over 3. Let's multiply that out. Actually, I can divide both these by 4.5. That's 3 over 2. That's great. So 3 times 3 equals 2x. X is 4.5. Did this bother you? I reduced by dividing by 4.5? Probably did. Okay, so if I did it the regular old standard way, I'd say 3 times 13.5 equals 9x. Not everybody thinks like me. All right, so 3 times 13.5, that's like 40.5. So I divide both sides by 9 and I get the same thing. Are you happy now? Okay, great. All right, so here's the one that's different than the other ones. The thing we did not see an example of from back here from these three things, we did a altitude example and we did a median example. Angle bisectors also works. Angle bisectors also comes this way. If you draw, so now we're just in one triangle. So this is significantly different than those previous examples. In one triangle, if you draw an angle bisector, you've effectively split the triangle into two new triangles. Those two triangles aren't necessarily similar, but there is some stuff going on about it. In fact, I know they're not similar, but there is some stuff proportional. This is way different than the other things we did because, again, I just said we have triangles that are not similar, but there are some proportions. It's two of the sides that are proportional. The third side, of course, isn't proportional because it's equal. JM is the same in both triangles. So this is kind of weird. Pay attention. All right, so you've got the angle bisector here. It turns out that KM is to LM like KJ is to LJ. I think the way they describe this here is maybe too wordy, or like the way they do this, segments with the vertex K, segment with vertex L. I don't think you're going to mess this up if you just realize that, all right, when we draw the angle bisector, the two parts that we just split this into, I guess that's what it says up here, right, are proportional to the two sides that were along the side of the angle that we just bisected. Again, like lots of stuff we've done in this chapter, it's harder to say than it is to just do it. So here's the angle bisector. Whoa, what's going on? Oh, this happened. I figured out why that's happening. All right. I have it in my last video, and I couldn't figure it out, and it was really messing me up. All right, so here's the angle bisector. Wouldn't hurt to just kind of draw this out to remember that's the thing that's dividing the two triangle parts. So stuff over here is proportional to stuff over here, but it's always going to line up nice. Like I can always say it this way. 4 is to 6 like x is to 13. I actually don't think, once you figure out that that's the things that are involved in the proportion, I don't think you're going to mess up what the proportion is. Again, 4, 6 bothers me. I like it as 2/3. 2 times 13 equals 3x, so x is almost 9. It's 26/3. Don't be afraid of fractions. If you want to decimalize it, that's your problem. Okay, find the value of x. Well, we have a angle bisector situation here. That means, yeah, this is the way Sketchpad does it. It means those are equal. Yes, that's an angle bisector. 11 is to, let's start down here. This thing is to this thing as 11 is to 14. Well, that's all fine and good, but I don't have all these variables named. 11 goes with 14 like this part goes with x. Well, I don't know what this part is, but I have this 20 here. If I have this 20 here, I know that this little part, this is a common trick these days. Be used to that. There's a lot of 180 minus x on the last test. If we know the sum, we can write a variable, or we can write an expression for that. So 11 is to 14 as 20 minus x is to x. Can't really reduce anything. Let me go over here and start solving it. 11 times x equals 14 times the mess. The mess is, oh boy, 14 times minus 280 minus 14x. Wow, this looks like it's going to be big. Okay, so then add on both sides, so 25x is 280. Oh gosh, I got to do some heavy-duty division. That's 10. You know what? It's 280 25ths. It's a little more than 11, I guess. So this is also the same as, divide everything by 5. That works. 40. Wait a second. 56. Oops. 56. Yeah, it's a little bigger than 10. Great, 56 fifths. That's perfect. There's nothing wrong with 56 fifths. Calculator would have made that a little faster. And I think there you have it. That's a short video. I will see you in class.